as an introduction to air quality in Cully. We really appreciate Verde being able to kind of come at the last minute. And with that, as context, I'm going to turn it over to Gregory to introduce the presentation. He helped organize our presenters and the presentation tonight. So Gregory, Raul will be able to share his screen, but if you want to do the introduction, we should be ready to go.
Yeah, just very quickly, I'll do a quick intro. My name is Gregory Sotier. I'm with the Cully Air Action Team. We've been focusing in on industrial polluters in the Cully community for a long time. The diversity of our community is really quite astounding and wonderful. And I think that video we just watched, thank you Verde for producing it, shows really what's at stake in our community in terms of the future of our air quality. We have a lot of young families moving into our community with housing that is being developed, and they need to raise their children in an area that has clean air. It's as simple as that. DEQ has been doing a lot of groundwork to set up the process for determining how these issues will be regulated. After a lot of requests, they set up an air monitor at Helensview School. And I believe that the data that we're going to be looking at today comes from that monitoring station that many of you were a part of asking the DEQ to install. So these are the fruits of that labor. And with that, I'm going to turn it over to Raul of the DEQ, and thank you everybody for being here.
Thank you so much, Greg. And just give me 1 second while I share my screen. Okay, can folks see that okay? We have two PowerPoints. Okay, perfect. Okay, great. So my name is Raul Preciado Mendez. He, they pronouns are both fine. I am the community engagement liaison at DEQ, and I'm happy to be here tonight. Very, very glad to be with you folks. I wanted to take a quick moment before we get started to just introduce some of the folks that are here with me on staff. So we have Kenzie Billings, who is our air toxics project manager, who is a co-presenter today. We have Lauren Wordis, Keith Johnson, J.R. Giska, and then we have folks, David Ferrer, sorry, all from DEQ. And then we have Julie Cifuentes and Holly Dixon from OHA, from the Oregon Health Authority, who have some ability to answer some of the more, Holly will be answering some of the more health-related questions if it comes to that at that point. So we're gonna get started here. So bear with me because I'm gonna have to click on both the slides to transition. So I don't think we necessarily need to go over this, but briefly, just if you're if you have any technical difficulties with Zoom, just feel free to put that in the chat, and one of the other, I'm sure Isha can help you out with that if we need it. So feel free to raise your hand and use the Ask Question feature. We will have a section in each of the PowerPoint slides where we have time for people to answer questions. So there is a Q&A session at the end that's much longer. So we have a couple minutes in between the sections to have people answer questions. But if we run out of time there, then we'll just continue, and then put your question in the chat or write it down, and then we'll get to it at the end. We have that time allocated to do so. If you're on the phone too, please press *9 if you need to raise your hand, and it'll let you do that. Okay. So the purpose of today's meetings is we have a couple goals today. So we want to review the Owens-Brockway approved emissions inventory. We want to get your input as a community on the different receptors, so the homes, schools, daycares, places of work that DEQ has used for its risk assessment. So we have a number of those that we've included, but we want to get your input on that. And then we want to answer any questions that you have related to Owens-Brockway or the Cleaner Air Oregon process. So it's just on here in the Spanish slide. It's an earlier version, but just make sure that you're, we have this in most of our presentations, just make sure you're being respectful and of other people's opinions and times. And obviously we're happy to answer questions that you might have. So I will turn it over to my colleague, Kenzie Billings. And Kenzie, whenever you need me to just switch slides, just say next slide. I'm gonna be fun.
Thank you so much. And thank you all for the opportunity to be here tonight. We're really looking forward to sharing the lessons that we've learned in going through Owens-Brockway's emissions, completing their emissions inventory, and to bring information to you to get your input before we take a look at and finalize the facility's risk assessment. So we're at a great pivotal point here to get information from you and answer questions you have before we move forward. A little bit of quick background about me. I'm an environmental engineer and I'm managing the risk assessment for Owens-Brockway. Next slide, please, Raul. Okay, so I would like to start with a brief overview of how the Cleaner Air Oregon, or CAO, process works. Our program is health-based. That means that facility emissions must meet established standards or they need to be controlled. The program has three main parts that are listed on these slides. First, a facility like Owens is called into the program and they're required to report emissions of up to over 600 pollutants in what is called an emissions inventory. This inventory summarizes both what types of pollutants are emitted to air and how much of those pollutants are emitted. The next step is that a facility must assess risk posed by those emissions to people who live, work, and go to school nearby facilities. This is done by, one, identifying nearby receptor locations, so homes, schools, places that people recreate like parks and places of work. And then two, determining how much of those pollutants are expected to be in the air at those receptor locations. The third part of the program is the final step, and that is to regulate based on the risk that is assessed. Companies are required to act if the levels of air toxics that they emit exceed health risk action levels. Next slide, please, Raul. I'll grab a drink of water really quick. So now that we have an overview of how CAO works, I'd like to give a bit more detail on that process. This diagram shows the risk assessment process from left to right. And the items in blue squares are actions that facilities must complete and that DEQ reviews and approves throughout that risk assessment process. If during DEQ's review, we require revisions, we request them of the facility and require those before we move to the next step. If DEQ approves a submittal, the facility moves to the next step in the process. We rely on facilities to prepare and submit data for our review, but we review that data carefully. And as you will see when we dive into the facility's emissions inventory, we request revisions when they're necessary. This graphic does not convey the amount of work required at each step of the process. I know there's a lot of information on the right end, which means there's still work to be done, but please note that the emissions inventory step is by far the most time-intensive step in this risk assessment process, and we'll give an estimate of project completion at the end of this presentation. In this case, Owens-Brockway prepared an emissions inventory that included air toxic source testing data that DEQ required be included in that inventory. DEQ approved Owens-Brockway's emissions inventory in March of 2021, so a month ago. We would like to talk more about what goes into an emissions inventory and share what we learned when completing that for the Owens-Brockway's Cleaner Air Oregon risk assessment. Next slide, please, Raul. Just a quick introduction to what all goes into an inventory, the questions that we're looking to answer when we approach these, and we require facilities to quantify emissions of these 600 plus pollutants are what is being emitted, where are each of the emissions coming from, how much of each pollutant is being emitted, and at what rate, and are there any controls on these processes to reduce emissions? And if there are controls, how well do they really work? Next slide, please, Raul. Most of you here are probably familiar with Owens-Brockway, and you know that they produce glass bottles and jars. I thought it might be helpful to review how those bottles and jars are made to understand where emissions might come from. So what you see here is a general overview of that bottle making process. Now, please note that the process that's pictured here is highly simplified, and it's not specific to Owens-Brockway at all. This process flow is just meant to give us context to how bottles are made, and it's not meant to summarize Owens-Brockway's process. So if you'll just follow the arrows along with me as I talk through this, the first step is raw materials like sand, baking soda, limestone, and what is called cullet, which is really just broken recycled glass. They're fed into a mixer, and we'll call this mixed material batch mixture. Excuse me. The batch mixture is then fed into a glass melting furnace where it is melted. So you'll see it going into the furnace and melting. Hot glass flows through a feeding device, which controls the size and shape of glass gobs that are then put into molds. Molded glass bottles are treated once the glass gob has been put into the mold has been, the glass has gotten into the mold and made the desired shape. Molded glass bottles are treated in a surface treatment process, and that just applies tin compounds onto the glass surface to close small cracks on the surface of the bottle that may have come up when you were breaking the bottle away from the mold. After that surface treatment process, bottles are annealed. You'll see that annealing furnace along the bottom of the graphic. And an annealing process, it's really just a heat treatment that reduces a material's hardness and makes it easier to work with. And then those finished bottles are coated and packaged for shipping. An inkjet printer prints identification numbers on the glass containers as they move on a conveyor belt before they're packaged and shipped. Next slide, please, Raul. So now that we have a general process overview for Owens-Brockway, I wanted to look at their facility specifically to show you some of the emission sources that are in their emissions inventory. The two primary emission sources for metals at this site are the glass melting furnaces. That's furnace A and furnace D. Furnace D has a single exhaust stack, and it's the northmost stack circled here. You'll see it in just the plain circle on this graphic. Owens has historically produced amber and green glass in this furnace. They primarily produce wine bottles and beer bottles, to my understanding, at this site. Furnace A has two stacks. You'll see it circled by the oval, and combustion gas that exhausts from these two stacks, it's alternately discharged between those two stacks every 30 minutes. And you might be wondering, there's a furnace A and there's a furnace D. Where are furnaces B and C? And that's a great question. This facility has the shells of furnaces B and C on site, but they're not functional. Furnace B was shut down in 1978, and furnace C was last operated in 1990. Next slide, please.
Hey, Kenzie, this is Keith with DEQ, and
Sure.
I just wanted to flag that we had a question in the chat.
Sure.
A question that asked what types of bottles are made at the facility.
Sure, Chris, I see that question now. Thank you. The primary types of bottles that are made at the facility are like beer bottles and wine bottles, to my understanding. But that can change based on what mold or production needs that they have. I'm happy to look into other details for you to get a more specific answer if that's helpful. Okay. Okay, so I'm going to talk about a few more emission sources here. The first is material mixing, which is where that sand, limestone, and recycled glass is mixed together, and that occurs in the area indicated. This process primarily emits particulate matter, including respirable silica. And the surface treatment that we talked about with the tin oxide to cover up any cracks that are in the surface of the glass, that vents to the area indicated. So you'll see it occurs in that main warehouse and vents through those two stacks. Exhaust gas from the surface treatment is routed to a baghouse, and ammonia is injected into the gas stream that enters the baghouse. So you're injecting ammonia to combine with excess tin, which is a metal, in the exhaust stream to form particulate matter that can then be removed from the exhaust stream. So if you're injecting ammonia and you have excess ammonia, it might not react with the tin and it would be emitted from the baghouse. And the other thing I'd like to mention is the boilers on site, they combust natural gas. So that's another emission source. Next slide, please. Just a couple more emission sources I want to identify here. I think it's helpful to have visuals and to be able to understand what is going on at this facility to wrap our head around emissions. Another thing that happens at this site is welding, which is just a process to join metals together. It's using high heat typically. The facility performs a few different types of welding for part repair. And these welding processes emit metals. Exhaust air from that welding is routed to and controlled by a fabric filter or a baghouse. And mold coating. Those molds for the bottles that we talked about earlier, they might fall into disrepair. And to fix them, the facility applies a coating to the molds that is then cured in ovens. That process emits organic compounds and sodium hydroxide. And the last process that I'll mention is image printing. You probably remember that we talked about an inkjet printer that prints identification codes on the sides of bottles that are fed along a conveyor belt before they're packed and shipped off site. That image printing process uses a compound called methyl ethyl ketone as both the ink carrier and for cleanup associated with printing. Next slide, please. So Owens-Brockway submitted an emissions inventory in 2017, and that was required as part of Oregon DEQ's prioritization of existing facilities to call in to Cleaner Air Oregon to complete a formal risk assessment. I'd like to reflect on that inventory to highlight data gaps that we identified once Owens was called into the CAO program. The first item that I'd like to talk about is the facility did not have site-specific source testing data for metals or other toxics emitted from furnaces A and D. As I mentioned before, furnace A typically produces amber glass and furnace D typically produces amber and green glass. Emissions from a few other on-site activities were not included in that inventory that was submitted in 2017. And that includes emissions from the mold repair, the image printing, and the welding that we just talked about. So DEQ worked with Owens-Brockway once we called them in to close these data gaps. The facility determined emissions from the welding that's on site for parts repair. We also determined emissions associated with image printing and glass mold repair. And one of the most noteworthy things, Raul, if you'll go to the next slide. Yes, absolutely. Sorry. Okay. One of the most noteworthy things that we did was we had Owens-Brockway source test. They source tested both at furnaces A and D to obtain verifiable data about metals and other air toxics being emitted from the furnaces. They tested during both green and amber glass production in furnace D. And this source testing occurred in May of 2019 and August of 2020. Next slide, please, Raul. And when you compare the 2016 emissions estimates to those in the emissions inventory that DEQ worked on and approved in March of 2021, some changes are significant. This information is all available online for your review. including the data reports, emissions inventory, and our comments throughout the review process. Those are all posted on the facilities webpage, and we're happy to send that to you. I think it's linked at the end of the presentation. I'd like to talk first about hexavalent chromium. As I mentioned earlier, Owens-Brockway mostly used source testing data from other facilities to calculate emissions from furnaces A and D in their 2016 emissions inventory. Owens-Brockway did use one total chromium value from a 2008 source test at their Portland facility. Hexavalent chromium emissions are significantly lower than what was in the facility's prioritization. In that prioritization in 2017, DEQ conservatively assumed that 100% of chromium emitted from the facility was hexavalent chromium. Source testing shows that this is not the case. The total chromium source test value used in the 2016 inventory is a factor of 10 larger than the total chromium detected during testing that was completed in 2019 and 2020. In addition, site-specific source testing showed that less than 1% of total chromium emitted from furnaces is hexavalent chromium. For example, source testing completed in August of 2020 showed that 0.12% of total chromium from furnace D is hexavalent chromium. The facility collected samples and analyzed them for total chromium and hexavalent chromium during that 2019 and 2020 testing.
Kenzie?
Oh, yes.
Oh, sorry. Gregory was asking if there were any upgrades to the industrial processes made to limit the releases.
That's a good question, Gregory. During the Cleaner Air Oregon process, to my understanding, no, there were no upgrades made to the processes. I'm happy to check in with our permit writer for the site to verify that that's true, but to my understanding, no, not during this risk assessment.
So just to clarify, and I'm sorry, the reason that these numbers have changed is primarily because originally the 2016 numbers were estimates. They were not actual tests.
Correct. So some of those numbers were source tests from other sites, and some of them were emissions estimates, which are not site-specific source testing data.
Kenzie, another question came in if these numbers are in pounds or as a percentage.
These are in pounds per year, annual emissions.
Thank you.
Mm-hmm. Okay, I'd like to talk about arsenic as well. Site-specific source testing showed that arsenic emissions from furnaces A and D are over 10 times higher than what was originally estimated in that inventory in 2016. The emissions estimates for arsenic used in the 2016 inventory, again, were not site-specific, and it's unclear what plant that emissions data came from and under what conditions that data was collected. The data used in the 2021 inventory is site-specific and reflects emissions associated with the amber and green glass produced at Owens-Brockway's Portland facility. I'll also add that our DEQ source test coordinator reviewed and approved a source test plan and was on site for Owens-Brockway's source testing. The majority of the arsenic emissions that are presented here are from furnace A. Next, I'd like to talk about lead emissions. Site-specific source testing also showed that lead emissions from furnaces A and D are higher than what was originally estimated in the 2016 emissions inventory. The emission estimates used in the 2016 inventory, were lower than emission estimates obtained during site-specific source testing in 2019 and 2020. I just saw a question come in. Has volume of glass gone up proportionally? Their activity levels, to my knowledge, I need to verify, but their activity levels have not increased substantially. They haven't fluctuated much, but I can verify that. Let me write that down really quick. Where was I? Ammonia. So let's go back to the surface treatment that I mentioned earlier, where you inject ammonia to remove tin from the exhaust gas from that surface treatment process. There is significantly more ammonia emitted from that ammonia injected baghouse than was previously reported in the 2016 emissions inventory. The amount reported in the 2016 inventory was an estimate for ammonia emissions from only ammonia injection. Comparatively, the 2021 inventory includes ammonia emissions associated with natural gas combustion, which is approximately 3,000 pounds of the 15,000 pounds that you see there. And it uses site-specific testing results to quantify emissions from the ammonia injection baghouse. That's approximately the remaining 12,000 pounds. The 2016 ammonia calculations were based on engineering estimates, again, not site-specific exhaust measurements, which is what was used in the 2021 inventory. And I see we have a question, which is perfect timing, because now I want to open it up for more questions from folks. So what do these emission levels mean in terms of human exposure and the potential for smelling any of the emissions, as well as potential for human health impacts? We have a couple of representatives from Oregon Health Authority on today, and I think it would be helpful for perhaps Holly to jump in if you'd like to.
Yeah, I'd be happy to. This is Holly. Can you hear me okay?
Mm-hmm.
Perfect. So my name is Holly Dixon. I'm a public health toxicologist at Oregon Health Authority, and I spend a lot of my time working with this team on the Cleaner Air Oregon program. And so your question about human exposure and what this could mean for human health is a wonderful one. And so it's pretty complicated, and that's why we're here doing a good job trying to understand what's exactly coming out of the facility. So the risk of a health impact that can come from chemical exposure depends on several different variables, different factors. And some of those include the amount that someone may breathe in, and also how frequently you might be exposed to that chemical. So the numbers that Kenzie just shared with you on that slide are from that emissions inventory. And those are numbers that are being generated right at the facility. So this is not the same amount that a neighbor of this facility would be breathing in at their locations. So the next step of the Clean Air Oregon process is going to be really helpful for us to understand that potential for human health impacts and what this program's all about. So that's what we're working on next. So that next step, we're going to be using modeling to actually estimate the concentrations of these emissions at those locations where residents, students, workers, and other people spend their time. And that's where we want to understand how it impacts their health. So this modeling information will give us that needed information to understand how these facility emissions impact the health. So we're really reporting on what's coming out of this facility, kind of at those furnaces, at these emission points. And this next step that we'll go into and ask you questions to give us feedback on is all going to be about, we want to get those air concentrations at those neighboring locations. So that's what we're trying to do, is get those human health impacts. And that's kind of that next stage. So we're working on that.
Holly, this is Isha. I just wanted to remind folks to please slow the pace of speaking because it helps with interpretation. And Holly, this next question in the chat might be for you. So the question is, what is the annual cancer risk per million and hazard index for all emissions?
Yeah, that's definitely for me. So there's different ways in our risk assessments that we look at health impacts. And one of those is for cancer risk, which we usually talk about in how many excess cancer risk per million people. And so that's what that means. And then hazard index is a way for us to look at risk for non-cancer health impacts. So things that impact the lungs, the skin, anything that's not cancer. So that's what the next step of that process is really going to do. So we don't have those risk assessment numbers now. That's what we're working on. What we really have is what's coming directly out of the facility And that next step is looking at what the risk numbers are to the neighbors. So we're working on that, and I don't have the numbers to share today.
Right, I would add to that, that's part of why we're here tonight. In the next section, we really want to go through the locations that we've identified as the closest locations to the facility, where the closest residences are, workplaces, schools, and daycares, to make sure we have those locations clearly identified before we assess risk. That is a critical step for the risk assessment itself. Let's see, there's a couple of questions. I see a question in Spanish. If someone could translate that for me. I see a couple of keywords, but just so I'm clear on the question asked. That would be
Yeah, I can translate that for you. Give me a
Mhm.
second. So about cancer, that can happen at any person's age. So age isn't a factor.
So you're asking about the incidence of age or incidence of cancer. Is it dependent on age? Is that right? Or is it
Yeah, the
not?
question is from Alma Mora, and it's
Mhm.
related. So the question is related to cancer. This can happen at
Mhm.
any age.
Yeah, so for cancer, got it. So that you're asking about what age do we take into account for cancer?
I think the question is more is if age is a factor in the cancer rates, or if the emissions are just affecting anybody regardless of their age.
And is that
This is Dave.
is there something? Oh yeah.
This is Dave with OHA. Is it okay if I step in for just a
Mhm.
second on that one?
Yeah, I think they added something else to the chat too, to expand on that.
Yeah, so it says what I'm referring to is about the pollution.
Okay, perfect. Yeah, Dave is a toxicologist at Oregon Health Authority as well.
Yeah, so I would just add that. So cancer, the biggest risk overall for getting cancer is age. So the older a person gets, the greater the chances the person will get cancer from any cause. And there's all kinds of different things, including pollution, but also including other things that increase risk of cancer. So and all of those things kind of pile up with age. So generally, the older someone is, the higher their risk is of getting cancer, generally. And then, and one of the risk factors, another risk factor is environmental exposures like this. I'm hoping that makes sense.
Okay. Okay. I have one question from Greg Bourget about the annual emissions. We are happy to send these slides to you, and we're also going to put them on the facility webpage. So if it's okay that we kind of catalog these questions and save them for the Q&A at the end, that would be fantastic, because I do want to get through. I know these are fantastic questions. I just want to get through the next piece, if that's okay with folks.
Yeah, that's great, Kenzie. We'll save the questions for the end.
Okay, thank you. Okay. Okay, so next I would like to jump into modeling emissions and take a look at where we're at. Raul, you can just go ahead and go to the next slide. That's fine, thank you. The Cleaner Air Oregon process. So as I said, we approved the emissions inventory. We did site-specific source testing. That was approved in March of 2021. The facility submitted what's called a modeling protocol and a risk assessment work plan at the beginning of this year, 2021, for DEQ review. Now that we know what's being emitted in detail, Our priority for tonight is to get the community's feedback as we review and approve the next phase of the risk assessment. And to complete this, we'd love your feedback to make sure that we have up-to-date information about where the community lives, where you guys go to parks, where you work, and where you go to school around this facility. Because in CAO, this information has a direct bearing on calculating risks. Next slide, please, Raul. Okay. DEQ models pollutant emissions using site-specific meteorological or weather data. And we do that to estimate how much of each pollutant is present at a receptor location. And you might be wondering, what are receptor locations? And those are locations where people live, work, and play. These include homes, schools, daycares, and places of work. They're locations where people might spend a few hours, or they might spend most of their lives. And in this program, we assess risk for both of those scenarios, both short-term and long-term risk. So we've identified what we understand to be the closest homes, parks, daycares, schools, and places of work on the following slides. And we'd like to ask you whether you have any new information for us. Next slide, please, Raul. So Owens-Brockway plans to model emissions up to 10 kilometers away from their facility. Tonight, we'd like to focus our discussion on those homes, schools, and places of work that we've identified as the closest to the facility. Those close-in features will be the greatest determining factor because that is where risks are typically highest. If you're aware of any receptor locations that might be closer, again, please let us know. We're looking to get that information by April 30th, and we'll have Raul's contact information at the end of this presentation, and it'll be sent out for you folks to be able to reference. Next slide, please, Raul. So as promised, we're zooming in. What you see here is an aerial map of the facility and the surrounding area. The facility boundary is boxed in red, and you also see the predominant wind direction indicated by the orange and blue arrows. You'll notice that wind direction changes based on the season. So the orange arrow indicates typical wind direction in summer, and the blue arrow indicates typical direction in winter. We'll be using this aerial photo on the next few slides. Next slide, Raul. Thanks. So this slide shows zoning in the area surrounding the facility. You will see that the area shaded in yellow, that's zoned for industrial use, and the area shaded in purple is zoned for residential use. The areas that are boxed in blue are schools and daycares that we've identified. And I'd like to identify those explicitly on the next slide. Thanks, Raul. So we've identified several nearby schools, daycares, and parks. These locations will be used to assess, again, both short-term and long-term risk from the facility. You'll notice that some locations listed on this slide, they're not pictured, and that's because they're farther away than those that we've identified in the picture as the closest locations. The nearest school is Helen's View School, which is about 1/4 mile from the facility. The nearest daycare is Joyful Heart Day School, which is about 1/2 mile from the facility, and it's located in the residential area. I believe it's in a home. And the nearest park is Johnson Lake, which is just north of the facility along the facility's fence line. Please note that residential risk is the most conservative category of risk that we assess, and will assess risk in the most protective way in a residential area, even if there is a school in that area. So in that case, for Joyful Heart Day School, we'll also be assessing residential risk there. Next slide, please. We've also identified the homes that are closest to the facility, and those are in the 2 areas indicated by white arrows. These homes are 1 to 2/10 of a mile from the facility, but it's important to note that all homes, not just those that are closest, are evaluated for health impacts. Next slide, please, Raul. In terms of looking at the closest workers to the facility, you can see that there are places of work right along the facility boundary, so right next to the facility, essentially. That means that both worker exposure, chronic and long-term, and acute, short-term exposure will be assessed at the fence line on all sides of the facility. Next slide, please, Raul. So all of that being said, actually, Raul, I think that I should turn it over to you on this slide.
Thanks, Kinsey. So what we want to do tonight, as we mentioned a couple of times, is that we want to get your input to make sure that we are identifying the correct homeschools, daycares, parks, recreation areas, places of work, and other important places where people are in the neighboring area close to the facility. So we listed a couple of examples, so some of the folks that, or some of the places that we know for sure. And we need this information from you prior to, so before April 30th. If you have questions or you want to see specific information on the modeling, so on the way that we've used the modeling for this risk assessment, you're welcome to go to our website. And if you have specific comments about this, so if you have input that you want to send, you're welcome to send it to me either via telephone, you can call me, you can send me a text message, or you can email me at the address listed below. And so this information we'll make sure to put in the chat before we finish up. And these slides will also be available, so you'll be able to do that. I think Keith has his hand up.
Thank you, Raul and Kenzie, and I'll be brief because I know we're running low on time, and there's other questions. I've tried to answer some of them in the chat. Hopefully that's helpful. But I just want to acknowledge on behalf of DEQ and OHA, we've given you a lot of information here, so if there are additional questions, we certainly want to have time here if possible, but we're happy to perhaps work with Gregory to set up some additional time. But this is a lot of new information. This is a really important milestone for us. We know this facility's been of great concern to this community for a long time, and it's been a concern to us as well. So while we're excited to sort of finally have this data and be able to move this process forward, we also want to move forward quickly and get the risk assessment done and be able to have that understanding of what these risks are. So whatever input we can get from folks here or other ways that will help us ensure we're overseeing and improving this risk assessment the right way is really important to us. We don't want to miss houses or residences or things like that.
What, like but see, they be, I could get just chicken too. I don't have to get the meat like the biscuits. I don't want biscuits. And even sides, I really don't have to have sides, but we.
Anyway, so I sort of lost my train of thought there, except just to say we appreciate your input and look forward to additional questions. And I see some hands raised, so I'll pause there. Thank you.
There's a lot of questions that are coming through in the chat, but just wanted to make sure you catch the locations being called out. So the facility itself and within a mile, the houseless population around there, as well as Alderwood Golf Course and Thomas Cully Park.
Thank you. Thank you for those. I'm taking a note of those now. Greg, I saw that you were asking about the annual lead and arsenic numbers in the chat. I can get those to you. Or maybe perhaps, Raul, could you bring that slide up? I think that it's slide number 15 in the English version. Yeah, and the Spanish version. Okay. Okay. By what factor or percentage do the emissions drop as you get further away from the facility, as in how much do pollutants dissipate as you get further away? That's an excellent question. The way that the facility is proposing to do risk assessment is what we call a level 3 risk assessment. There's 4 different levels of risk assessment. The first is very simple. It uses dispersion factors, which would have basically a universal dispersion rate, which is very similar to what you're referencing here. As I said, the facility is proposing to do a level 3, which uses weather data, and that kind of changes the distribution of pollutants depending on which way the wind blows and specific stack parameters for emission units that are on the site. But typically, to generalize that, typically the impact of emissions dissipates as you get farther away from the facility.
Hi, this is Vina. I have a couple of things. One, I just want to call out, we have an open board position. There are a lot of people on this call. We're going to be voting in May. If you want to participate in this conversation and keep advocating for the neighborhood, please decide to run for the board. There's that. Just a little selfish plug. And then I'm really curious, the estimates that Owens-Brockway gave in 2016 are so different from what was actually being produced in 2021. Why do we allow companies to guess? Like, why is that? I mean, is that something that continues to be acceptable, that like some other company that is producing pollutants would be able to say, well, we think this is our emissions?
And Z, I could probably take that. Thank you for the question, Vina. So back in 2016, when we got this information, this was sort of the first time we were getting this kind of specific information about facilities in Oregon. So it was part of a statewide ask of, gosh, thousands of facilities. And so we did go for the larger facilities. We did go through some of those inventories pretty carefully, but that was before we had Clean Air Oregon, before we had sort of a program to sort of regulate on that data. So when we call somebody into the program, we say you now have to do a Clean Air Oregon assessment, which we've only called in 14 so far because there's a lot to do. That's when we really crack open these assumptions and truth test them. We have actually required many people to do testing, some for the first time. So it's a little bit of a slow process. So again, the 2016, some of the information for some facilities actually was pretty good, but some, again, is just a little bit more estimations because some of these people hadn't tested.
But just to clarify, do we still let people guess? Or are they required to actually do the testing?
A lot of times we allow them to estimate. Yes, I mean, we can call that a guess or estimate. Again, sometimes those estimates we know are better than others. And for Cleaner Air Oregon, and for certain types of pollution that people are specifically regulated on, they do have to test to verify those numbers for some of it.
So I see Elizabeth has her hand raised, and after Elizabeth asks her question, do you want help moderating the chat, or do you want to mine through and pick up some of the questions?
I think that, oh, go ahead, Raul.
No, I was just going to say, I just wanted to do a time check. how much time do we have left? Because we just have very brief next steps, and then basically we're done with the presentation. So
yeah, we got about 9 minutes, so we can do some more questions along with next steps.
okay, great. Yeah, your help moderating some of those would be great, just so I'm not you know, showing everybody the chat and trying to scroll through that for the screen share.
Sure. Yeah. So there's a question from Bruce. Are you focusing on only human health, not looking at effects on the ecosystem of the Columbia Slough Wildlife Area? So this is a question about human health versus ecological system impact.
Right. Our program focuses on human health risk assessment, both short-term and long-term impacts. I don't know, Keith, if you want to add anything to that.
Yeah, it's not, it doesn't look at the wildlife impacts or so forth. There is a mechanism in the program that counts for bioaccumulation. So there are assessments made for certain contaminants if they are known to bioaccumulate in soil or things like that. But we don't assess, it's beyond the scope of the program to assess risk to wildlife or other sorts of things like that.
Okay, thank you. Kathy asks, should Sacagawea Park be included? And I'm assuming that she is suggesting it should be. So that's a note for Sacagawea Park for testing.
Okay, I've got a note for Sacagawea Park.
Yeah. And then Talia asks, how do these numbers compare to what a safe amount in the air would be? And Talia, you can come off mute, but I'm assuming, do you mean the overall numbers or one of the specific pollutants?
Yeah, just it would be helpful to have context for each of the pollutants, like how far is this above a normal threshold or a safe threshold?
Well,
yeah.
Oh, go ahead, Holly. Go ahead, Holly.
Yeah, I was just going to reinforce what I had been saying about how that these numbers that Kenzie was sharing were coming straight out of the stack, you know, right at the furnace at this location. And really, to understand how this might impact someone's health, we compare numbers that people are breathing in to what scientific studies have shown, what those levels could be that might hurt someone's health and what those health effects could be. So we really need to know what is that amount that people are breathing in order to do that analysis. So we're really trying to get that information through modeling in this next step. But at this time, we don't have information about health related to these numbers coming right out of the furnace because that number will be quite different for someone nearby breathing in air. And Kenzie, sorry to cut you off if you have anything to add.
No, that's okay. That does a better job than I would have. So thanks, Holly.
Well, and I'll just add real quick. That is a great question, and that is why one of the reasons we're here tonight is to make sure we understand how to assess that risk. So this amount of lead coming out or something, you know, another contaminant coming out of some cement manufacturer in Eastern Oregon that doesn't have anyone living or working within 3 miles of it, you know, there'd be a much different safe level there. You could have a lot more coming out before there was a problem. So getting input and setting and understanding where people are in this community is definitely part of doing that right, that correct assessment.
Thanks. So I'll just keep firing them off until you want to move to next steps. There was a comment from Gregory that there's high levels of arsenic in the soil as well, and is DEQ taking that into account for the high levels of concentration of arsenic?
Yeah, I can take the first stab at this one, and then if DEQ has anything to add. But yeah, definitely in urban areas especially, there are concentrations of metals, including arsenic, in that urban soil. Especially in gardens and around homes. So there definitely are those things in soil. So for arsenic, what we do in this program to account for that people might be exposed to this chemical in multiple ways for arsenic, when we are looking at cancer and non-cancer health effects, we actually apply what we call a multi-pathway adjustment factor. And so that's a number that we account for and apply to that toxicity information that accounts for actually contact with soil. If someone accidentally eats the soil, if it's in contact with their skin, thinking about uptake into garden vegetables as well, and eating things from that garden. So there is a factor we apply specifically for arsenic to take a look at that in this program.
Great, thanks. And I think we have time for one more question. Elizabeth had her hand up for quite a bit. So Elizabeth, if you want to come off mute and ask a question or put it into the chat, we'll see if we can get that answered.
Oh, I was trying to, I have a question about, I remember last year when we have a meeting at the church, they were saying something about the fabric of the glass having a new permit to, I think so, keep working. I don't remember exactly what type of permit they were trying to have. Is it similar to what you guys are saying?
You're asking if they have the permit that they have right now, is it the same as what we're working on at this time?
Yeah.
So the facility is currently permitted to operate in the state under our state permitting program. We have this Cleaner Air Oregon component, was adopted a couple of years ago. We've been working with Owens-Brockway since 2019 on their risk assessment, which is an additional component to that permitting for the facility. It requires looking at emissions with a finer toothed comb, looking at more toxics, and then evaluating risk to see if we need to have health-based permitting requirements for this facility. Previously, we did not have a health-based permitting program. So Cleaner Air Oregon is that health-based permitting component that we have now as a regulatory tool.
Okay, thanks, Kenzie. So maybe we can move to next steps. And I know there's a lot of unanswered questions. So if you have a pathway that we could get those to you, and that would be great.
That is part of the next steps. Thank you so much for the segue. So basically what we will be doing next, like I mentioned earlier, we're asking that people reach out to us if you have any information on receptors, so different places that that you know of that are nearby. Just to be very clear, in the modeling that we've done, we have residential zones that are rated at a higher level. So those include daycare facilities, but we just want to make sure we have as accurate a picture as possible. So when you're providing us that information, it'll really help us when we're modeling exactly who and what kind of activity is happening near that facility. So again, please make sure you check up on our website, which is linked in the presentation here, but I'll make sure to put a link in the chat when I'm done screen sharing. We have updated that information and that's ready to go right now. If you have additional questions about this presentation or anything related to this facility, please feel free to give me a call or an email. I specifically work on Cleaner Air Oregon, so if for whatever reason I'm not able to answer your question, I'll try and find someone within the organization that works on something similar. And if not, I'll try and refer you to somebody else. But I'll do my best to answer everybody's questions and follow up. I see that Greg has his hand up.
Yeah, I just, well, I really appreciate OHA and DEQ coming out here, but what are we going to do next? We know what the problem is. We know that arsenic, lead, ammonia, sulfur dioxide, and many of these other pollutants cause real and significant health problems and effects. We know that even though DEQ says they've been working with Owens-Brockway, that Owens-Brockway has not done any upgrades to filtering out these toxins from the emissions going out of their stack every day. If you drive by the facility at 7 a.m., you can see the cloud over the facility. During firestorm season, that company is still pumping out the toxins, which is compounding the problems. I'm speaking here for myself, but I hope I'm speaking for the whole community, and I'm saying, DEQ, OHA, what next? What are you going to do about this? What can we do about this? Because tomorrow morning, they're going to be releasing more lead, more ammonia, more sulfur dioxide, more greenhouse gases, and more arsenic into our airshed.
That's a great question, Greg. And the tools that we have in our program, next steps are dependent on the outcome of the risk assessment. And we understand that it's pressing to get that risk assessment done. So then we know which path we need to take. If the risk assessment comes back and says that the facility is required to reduce risk, then they'll be required to submit a risk reduction plan and reduce risk. If they are required to demonstrate that they have the best available control technology on each of their emissions units, they will be required to do that and demonstrate that they have that on all of their emission units. But those steps depend on the outcome of the risk assessment. And that's why we need input here by April 30th before we approve the modeling to get that risk assessment done to move to those next steps.
Okay, thank you, DEQ and OHA. We really appreciate you coming.
Greg, I just had a question.
Sure, yes.
I'm so, and maybe we're just on the same page here, but I'm so confused as to why we can't just say that emitting 500 plus pounds of lead is not okay. Like, why do we have to do all of this modeling to figure out where that lead is going? It's coming out of their stack.
Yes, it is the law. The law basically allows them to release the pollutants. They're a Title V or Title V polluter under the EPA regulations. Under Oregon state law, previous to Cleaner Air Oregon, they could pretty much release whatever they wanted. All I can tell you is that things are getting better slowly. And we have to keep on putting pressure on OHA and DEQ and Governor Brown. We pass regulations that actually serve the people rather than protect these polluters. That's my take on it. I don't know. Other people have different takes. There's the whole jobs versus environment tack, but I kind of feel that we have to further regulate these polluters, and Cleaner Air Oregon is our best latest hope towards that process. But Cleaner Air Oregon really just came into effect in January of 2021. And this focus on Owens-Brockway and a couple of other major polluters in the Portland region is DEQ's first step in this Cleaner Air Oregon process of further regulation. I don't know if that is the answer that you want to hear, but that's basically it. It's regulators have done a very, very, lobbyists have done a very, very good job, slanting the playing field to their benefit.
So Gregory, thanks for that. I'm just transitioning.